So the last shape that we're going to find the area for is a circle. And a reminder of what area is. An area is the number of unit squares that fit in a two-dimensional figure. Now, I didn't draw grid lines on the circle because it will be really hard to count how many squares there are in the circle because the circle's round. But what we're going to do is we're going to do kind of like what we did with the triangle, use transformations to determine what the area is using what we already know. So I marked out the circle. The blue from the center to the end of the circle is what we call the radius. The radius is the length between the middle to the end of the circle. And it doesn't matter what point of the end of the circle you pick, from the middle to the end would have the same radius. We're going to denote that as R. The circumference means the length around the edge of the circle. In previous classes, you learned that the circumference is 2 times pi times r. We're not going to prove that here, why it's 2 pi r, but the length around the circle is 2 times pi times r. And if you don't remember what pi stands for, pi is approximately 3.14. I'm just going to leave pi as it is. It's a decimal that repeats forever. I'm not going to plug in 3.14. If you want to, you can. Okay, so I have my circle here. And what I'm going to do is I'm going to cut up my circle and rearrange it in a figure that we already know. All right, so what I did here, you guys, is I cut up my circle into multiple wedges. I believe it was 16 wedges. If I was a magician, I would have cut it infinitely thin as possible, as thin as I possibly could. But I'm not, so I just cut it into 16, and it's approximately this wide. All right, so I cut out these wedges, and what I'm going to do is I'm going to rearrange the wedges into a figure that we're all familiar with. Okay, so I rearranged my circle and it looks to a four-gon, a four-sided figure. I'm not an artist, it's not perfect, but you get the idea. So remember, in the original circle, the radius was blue and the circumference was red. The circumference is the length on the outside of the circle. So where did the radius go and where did the circumference go? Well, I noticed that the blue radius is on this side. It is the length of the side of the four-sided figure. Okay, the radius is right over here. I'm going to denote that as R. Now, where did the circumference go? The circumference, the length around the circle, I marked in red. Well, I see red in the bottom of the figure, and I also see red on the top of the figure. In other words, half of the red part, or the outside circle, went to the bottom of the four-gon, and the other half went to the top of the four-gon. So I'm just going to denote the bottom. I'm going to write here half of the circumference. Okay, so half of the circumference. The circumference, the whole circumference, we know is 2 times pi times r. I'm going to write that here. 2 times pi times r. But this is not the whole circumference. This is only half of the circumference. Since it's half of the circumference, I'm going to split it in half, or in other words, I'm going to divide by 2. So now this 2 in the numerator and the 2 in the denominator, I could cancel those out, and what I'm left with is just pi times r. So pi times r is this whole bottom length right here, pi times r, and this the side length is r. Okay, cool. So now we have the measurements of the sides. We're going to identify this shape. This shape looks like a parallelogram. If the wedges were infinitely thin, it would look more like a rectangle. But right here, we have a parallelogram. And the area of a parallelogram we've determined is length times width. So that is what I'm going to do here. The area of the circle that I cut up is going to be length times width. And I also wrote the area of parallelogram here. I forgot about that. Okay, what is the length of the figure that we created? It is r. So for L, I'm going to rewrite it as r, the radius. And the width of the figure we determined was pi times r. So I'm going to, instead of w, I'm going to write pi times r. Okay, I'm going to rearrange my terms. Instead of r pi r, I'm going to rewrite it as pi times r times r. And we're going to remember, because this is a repeated multiplication, I'm going to rewrite r times r as r to the power of 2. So pi times r to the power of 2, or pi r squared. So the area of this whole figure is pi times r squared. And you might be asking, okay, well, that's the area of this parallelogram, but what's the area of the circle? The area of the circle will be the same thing. Remember that we cut up the circle and rearranged it. We didn't take anything out, we didn't add anything in. We kept the whole figure the same. We just cut it up and transformed them into this figure. So therefore, if I rearrange it back to a circle, I won't because it's annoying, but if we did rearrange it back to a circle, it would still be pi r squared. I'm going to rewrite it up here. The area of a circle equals pi times the radius to the power of 2.